Hi everyone. In this session, we are going to discuss about internal resistance of a cell. Okay. So we already studied that what is resistance. What is resistance? When an electron passes through the circuit, it offers some obstruction to the movement, right? Okay. So now we consider the case of cell. Inside the cell or through the electrolyte also, current is moving through the form of ions. Okay, right now that's also a kind of charge carriers. So that charge carriers also during the movement, it offers some obstruction for the movement. Okay, so electrolyte also offers some obstruction to the movement of these ions inside the electrolyte. That is what we call as internal resistance. Okay, internal resistance means it is obstruction offered by the electrolyte for the movement of ions inside the electrolyte or inside the cell. Okay, and resistance we used to represent with the capital letter. Here internal resistance we are representing with the letter small r. Okay, so internal resistance is represented by the letter small r. Okay, we studied what is voltage drop. Voltage drop is represented by the letter small v, and according to Ohm's law, how can we represent V? V is equal to capital I. Inside the cell and outside the cell, the current drawn will be capital I into R. Okay, voltage drop means it is a voltage inside the potential difference inside the electrolyte, and R is the internal resistance. So we can represent voltage drop is equal to I into R. If we represent this internal resistance in a diagrammatic form, we know that how we used to represent the cell. Cell is always represented with this way. Right now, if you want to particularly mention the internal resistance, we have to add a resistance symbol here. Then it should be inside a box. Okay. So this box setup with the symbol of cell and the symbol of resistor will show the internal resistance. This is epsilon and this is R. Okay, so this entire setup shows the representation of internal resistance in a circuit. Now we'll see the relationship between internal resistance and terminal voltage. Okay, so for that I am connecting the external circuit with another resistor. Okay, resistor R. The total available potential difference in the circuit is epsilon. This is internal resistance and this is the outside resistance. So what is voltage drop? The voltage or the potential difference available between these points, that's outside the cell, is known as voltage difference or terminal voltage. Okay. So in this circuit, the total resistance is equal to R plus R. Internal resistance plus external resistance. Okay. Now, we'll see the amount of current drawn from the circuit. How can we find out the current? V is equal to, here also we are using the application of Ohm's law. V is equal to I into R. Right? Or I is equal to V by R. What is I? I is equal to V by R. What is V here? Epsilon. Terminal voltage, EMF of the cell divided by R plus R. Okay. Total available potential difference is epsilon divided by total resistance available in the circuit. So this is the way how we can find the current drawn from the cell through this setup. From this equation we will find out what is EMF. So EMF is equal to I into R plus R. Consider this as a first equation. Okay. So we are going to find out what is the value of this R. Okay. Then what is terminal voltage? Terminal voltage is equal to I into R. Consider this as second equation. Then what is the voltage drop? Small v is equal to I into R. Okay. So we are going to merge these three equations together epsilon is equal to V plus V, or voltage drop is equal to epsilon minus V. Okay. Now we'll connect internal resistance with this EMF. Okay. So from this equation, what is R? R is equal to V by I. Right? So R is equal to V by I. What is V? V is equal to epsilon minus capital V divided by I. From this equation, what is I? V by R. Right? Okay. So I'm going to substitute instead of this I as epsilon minus V divided by V by R. Okay. So this R will go up. We will get it as epsilon minus V divided by V into R. Or we can write it as, how can we write? Epsilon by V minus 1 into R. So internal resistance is equal to epsilon by terminal voltage minus 1 into resistance available in the outside circuit. So we have to know, we should know all these main equations. So depends upon the data given, we have to choose the right equation to solve the numericals. Let's see the factors affecting the internal resistance. The first factor which affect the internal resistance is surface area. Okay, surface area of the electrode. So surface area, as the surface area increases, the internal resistance decreases. Or we can represent as internal resistance is inversely proportional to the surface area of the electrode. Okay, it is about the electrode. Okay, as the surface area increases, the internal resistance of the cell decreases. Second one, the distance between the electrodes. Okay, distance between the electrodes, I will represent it as D. So as the distance increases, the internal resistance also increases. As in the case of normal resistance, we studied that as the length increases, the electron need to travel that much length or distance. Same way here also, as the length of the or distance between the electrode increases, the ions has to travel a long distance. Same way, the internal resistance is directly proportional to the distance between the electrodes. Now, third factor, the material of the solution or electrolyte. Material of electrolyte. Okay. If it is less ionic, less resistance. If it is greater, the concentration is more, the number of ions present in the electrolyte will be more. So, it offers more resistance. Okay. Fourth one, temperature. As in the case of normal resistance, we studied that as the temperature increases, the resistance offered by the circuit increases. But here, it is inversely proportional. As the temperature increases, it offers less resistance and in the electrolyte, and as temperature decreases, the internal resistance offered by the electrolyte is more. Or we can represent it as it is inversely proportional to the temperatures. So these are the four factors which depends upon the internal resistance of the electrolyte or a cell. Thank you.